All right, so example 22 is under the heading this divisibility, test, and mathematical induction. Example 22 says, using mathematical induction, show that 9 to the power n minus 1 is divisible by 8 for all natural number n. So as usual, let's start by saying that Pn is this statement that they're saying, that 9 to the n minus 1 is divisible by 8. Saying that something is divisible by 8 is the same as saying it is equal to 8 multiplied by a whole number. So A here is a whole number. Let us test if the statement is true when n is equal to 1. So P1, that's when n is equal to 1. On the left side, we have what? 9 to the 1 minus 1, which is equal to 9 minus 1, which is equal to 8, which is equal to 8 times 1, which is the same as saying 8 times a whole number. In this time, the whole number is A. So the whole number A here in this case is 1. So the statement is true. So now I can say Pn is true for n is equal to 1. Next, I'm going to assume that Pk, which is the statement 9 to the power k minus 1 is divisible by 8. So that means it's equal to 8 multiplied by a whole number, b. We're going to assume that this statement is true. Then we are required to prove that P k plus 1, which is the statement 9 to the k plus 1 minus 1 is divisible by 8, in which case it's equal to 8 multiplied by a constant this time, which is c. So what we're going to do now is sort of like a reverse application of a law of indices. 9 to the k plus 1 minus 1 is the same as saying, so we need to show that 9 to the k plus 1 minus 1 is equal to 8c. This is equal to 9 multiplied by 9 to the k minus 1. So this is a reverse application of the law of indices that say like a to the m times a to the n is equal to a to the m plus n. It's a reverse application of that. All right. Now, from this step, from step 2, which is here, we can show that 9 to the power k, 9 to the power k is equal to 8b plus 1. Positive one, negative 1 goes over and become positive. So I can replace the 9. So this becomes 9 multiplied by 9 to the k, which from step 2 is equal to 8b plus 1 minus 1. Distributive law, this becomes 9 times 8b. 9 times 1 is 9 minus 1. So now I have 9 times 8. If you want, you could put 72. It's up to you. So you could put 72b plus 8. At this point, you observe that 8 is common. So if I factor out the 8, I'm going to get what? 9b plus 1. So then now we're going to bring in a little reasoning. Remember, B is a whole number. If you multiply 9 by a whole number, you're going to get another whole number. And if you add 1 to that whole number, 9b, you're going to get another whole number. So 9b plus 1 is a whole number, and I'm going to call the whole number 9, 1 plus b. I'm going to call that c. So this is equal to 8c, where c is the whole number 9b plus 1. So now I just showed that 9 to the k plus 1 minus 1 is equal to 8c. After that, now I'm at step 4. This was step 3. That pk plus 1 is true when pk is true. Therefore, En, which is the statement 9 to the n minus 1, is divisible by 8 is true for all n, which is an element of the set of natural numbers. And this is how you do a divisibility proof by induction.